Okay, multiplying decimals time. Just as with adding and subtracting, we are going to start out with estimating, and we have this problem up here that we are going to start with 1 and 23 hundredths times 4 and 5 tenths. And so a very easy rough estimate would be this whole number is 1. This is between 4 and 5, so we could say 1 times 4 or 1 times 5. In this case, I went with 1 times 5, and I'm crossing everything out. My estimated answer is 5. Okay, so how do we actually approach these problems? When I talk to students about multiplying decimals, after we've done the estimating and we're thinking about what's logical, we still have to set up the problem. So I always ask them to set up their multiplication problem in the same way they set up a whole number multiplication problem. And so if my problem were 123 times 45, I would set it up this way with the numbers justified on the right. I will do the same thing with my decimal multiplication problem. I will not worry about setting them up and lining up my place values, although they can do that. They will still get the same answer, but they will have more steps in the process. They will have more multiplication steps, more zero placeholders, potentially more opportunity to make a mistake, especially when the numbers get longer, like this one here. So if they do that, it's not going to give them a wrong answer. It's just going to give them more work to do and more potential for an error. So I ask my students to set it up this way. I have a feeling that in 5th grade, there may have been some teachers that asked students to set it up this way so that they're always doing it the same way, adding, subtracting, multiplying. But I did not ask them to do that. I asked them to have everything justified to the right. So they do that. And then they multiply just like they do with whole numbers. This is my whole number work right here. This is my decimal work. I do not have my students put any decimal points in these rows of work. I have seen students put decimal points in these rows of work, and I have wondered if previous teachers may have asked them to do so. If they did that and they were thinking about what is 1 and 23 hundredths times 5 tenths, they might put a decimal point here. And what is 1 and 23 hundredths times 4? They might put the decimal point here. And then when they put it in the answer, it kind of lines up. The only problem I saw was that students would have decimal points in different places that didn't line up. So they might have this one here and this one here, and then that did not lead them to a logical place to put the decimal point in their answer. So I always encourage students to have no decimal points in this work because it was more confusing if they did. All right, so once we've got the work done, we place the decimal point in the answer. Now, if we think about our estimate, as we talked about in other decimal lessons, our answer is supposed to be close to 5. The only place we can really put the decimal point so that it is very close to 5 is between the first two fives, 5 and 535 thousandths. If we put it before the 5, we haven't even reached 1, and that's not close. If we put it after the 5 here, that's 55, and that's not close either. So putting it here between the 5s makes it closest to our estimate. If we follow the rule for placing the decimal, we would count how many digits are to the right of the decimal point in the problem. There are 1, 2, 3. The 2, the 3, and the 5 are all to the right of the decimal point. So that's 3 digits to the right of the decimal point. And sometimes teachers have them write it this way. There are 2 to the right there, plus 1 to the right there, means I should have 3 numbers to the right of the decimal point in my answer. And having placed it right here, that is what I have. I have 1, 2, 3 to the right of the decimal point. So that is the basic idea of decimal multiplication. I'm going to do a couple problems here just to show some work. So 4 and 2 hundredths times 8 and 5 tenths. And I'm going to, again, keep them justified. I do write my decimal points in my problem, and then I'll do the work. So 0, carry the 1, 20, carry the 2, that's 7, 0 as the placeholder there because now I'm multiplying by the next number. 8 times 2 is 16, carry the 1, that's 1. 8 times 4 is 32, carry the 3, that's 11. So if I read my digits correctly, 0, 7, 1, 9, 1, 1. Now, I did not estimate ahead of time, but if I estimated, and I want to make this easy, this is 14. 8.5 is close to 10. I'm going to make this 140, right? So 140. Now, I don't have 140 in my answer anywhere, but I can kind of think about this and say, if I put it before the 1, is that close to 140? No. If I put it after the first one, no, that's only 1. After the second one is 11. After the third, that gives me 119. 119 is not super far from 140. If I went one more place over here, that would give me 1,191. That is not close. So the only place I can put it so that my answer is close to 140 is here after the 9. And then I can double check it with my rule. I have 2 numbers to the right of the decimal point here and 1 here. That means I should have 3 to the right of the decimal point here. 1, 2, 3, and that checks out. I like to give students problems with lots of zeros sometimes, just to help them carefully keep track of everything. Okay, and to just have practice with middle zeros. 14, carry the 1. 2 times 0 is 0 plus 1. 2 times 0 is 0. 2 times 10, I'm sorry, 2 times 5 is 10. And then I could do more rows of zeros, and some students will do that. They'll put their 0 placeholder, they'll multiply through by 0 every time, but it's really not necessary. I didn't estimate this first, so before I decide to place my decimal point, let's estimate. 5 times almost a 0. So this answer is almost nothing. I mean, 0.2 hundredths is very close to 0. So 5 times 0 is really close to 0. So where would my decimal point go so that my answer is close to 0? It would, if I put it after the 1, my answer is 1. That's kind of close to 0. If I put it here, it's 10. So that's not close. So it could be here. But this is where I then would want to double check with my rule to make sure I don't have to add any zeros in front of it. 1, 2, 3, there are 3 numbers to the right of the decimal point there, and 1, 2, there are 2 there. So I should have 5 to the right. 1, 2, 3, 4, 5. In this case, it works out. I didn't have to add any zeros to the left of these digits. And my last one, 15 times 6 and 645 thousandths. I would encourage students to put the number with the larger digits on top in the problem. Because if they put the one with larger digits on the bottom, then they end up with 3 rows of numbers to add. If they put this one on the bottom, then they only end up with 2. And it really doesn't matter which one goes on top or which one goes on bottom. Commutative property says I can put them in any order I want, and I'm still going to get the same answer. This one does not have a decimal point. As we talked about in adding, the decimal point would be, or subtracting, would be here, but it really doesn't affect our decimal placement at all. So estimating this one first, this is 15 times 0.6. 0.6 is kind of close to a half, so I could estimate this to be a half. And half of 15 is about 7.5. So we'll say that our estimate is about 7.5. Now, 645 thousandths is more than half. So if we think about that, I'm multiplying by more than half. So my answer will probably be more than 7.5, but that's a good place to start. 5 times 5 is 25. Carry the 2. 20 plus 2 is 22. Carry the 2. 30 plus 2. Carry the 3, and that's a 3. I add my 0 placeholder. 1 times 5 is 5. And I'll tell you what, 0 placeholder in 6th grade, they still forget to add this at the beginning at this part of the problem. So it's just something to be looking out for. 1 times 4 is 4. 1 times 6 is 6. 1 times 0 is 0. Add those together. 5, 7, 6, 9, 0. Now, where can I put the decimal point so that it is close to 7.5, but more than 7.5, we figured? Well, if I put it all the way over here, that's not even close to 1. If I put it here, it's not 1. If I put it here, it's 9.5, about. If I put it here, it's 96. So this is the only logical place to put it, 9 and 675 thousandths. And if I double check, 1, 2, there are 3 numbers to the right of the decimal point here. There are no numbers to the right of the decimal point there. I should have 3 numbers to the right of the decimal point here. All right, that is an overview and a few examples there for multiplying decimals. Let me know if you have any questions.